Hey everybody, and welcome to Thorp, Washington and the Dudley Cliffs. There's some rock stories here involving these white rock layers that I think might interest you. Geology 101 lab, virtual field trip, Thorp. I'm your instructor, Ned Zentner. Thanks for joining us. Let's get started. So like we did up at Menashtash Ridge, we want to do the same thing here. We want to be very basic in our observations. So let's pull back from this cliff first of all. Actually, I can show you. The Yakima River is right below us. It's a nice spot. All right, so the task at hand is to make some basic second grade observations to begin with. What can we observe? Well, if I hold the camera steady for a second for you, I'm hoping you can first of all notice that there's layers here, and especially as we go from bottom to top, each layer is a little different from each other. There's also this rather impressive pink ball. So as we go from bottom to top, it's kind of a layered rocky unit, then a big fat massive unit, then this pink ball, then more layered rocky stuff, then another kind of fat unit, layered rocky, fat, layered rocky. So we alternate between these kind of fat, concrete looking things and then these rocky layered units in between. And then I don't know what we do with the ball. So it's a semi-busy highway, and back in the old days I used to have students huddle along this narrow shoulder across the way, and a bunch of loose stuff's falling down on us, and then I finally came to my senses after a couple of years of doing that. Senses, I think I said census. It's not what we want. But I've got my eye on the highway here. It's quiet at the moment. So let's go over and now just look at the difference between a big fat layer and a layered rocky unit. There's some amazing detail here. And I'm down on my knees here. All right. So these rocks are rounded, and each rock is different than its neighbor. Would you agree? I'm down in this layered rocky unit. Let me pull back for a second. And I hope that you can see that this layered rocky unit has a lot going on. In other words, we have these round stones, each different than their neighbor, but there's spots where we don't have layered, rounded stones, and we just have kind of this layered stuff. Hopefully the camera is picking up some kind of sparkly, fresh minerals as well. It's kind of breezy. Might get a bunch of eyes full of stuff, but let's try it anyway. I'm going to walk upwind here, and we're still just focusing on this layered rocky unit here. I'm walking in this kind of loose sand here. hopefully as we kind of skim by, I don't know, is the light any better if I go this way? I can't tell what's better for you. I'll give you both. So it's an attractive outcrop to be sure. And I'm hoping that you're picking up on the fact that many of these fine layers are not perfectly horizontal. In other words, there's some cross beds within this layered material. Let's go way over here. I see some decent cross beds. Well, even up in here, this is pretty good. You kind of see that there's some kind of tilted layers, and then there's some horizontal layers as well. Here's a decent spot. We're just trying to make observations now, right? We're not trying to tell a story yet. Great exposure, accentuated by putting Highway 10 in here. But I assume it was a pretty decent exposure of these layers even before the road was put in, because the Yakima River is just across the way. I mean, this thing's been just dying to come out of the cliff. It's been here for 10 million years. Okay, so can we observe some of these? This is a rhyolite. This is an andesite. This is an andesite. This is a rhyolite. These are volcanic rocks that are common up in the Cascade Mountains. Lots of rhyolites and andesites. In other words, not basalts, typically. You can see some hornblends, which are the black kind of needle-like minerals in here. Okay, so a bunch of light-colored volcanic stones, but then this cross-bedded material within it. So next step is to observe what's above, and notice how quickly we get out of the layers and how quickly we lose the rocks. So again, our nose is right on the outcrop here, but I'm hoping you can see, I can't get any higher than this. I'm a tall guy, I'm not exactly a drone though. Can you see how we change rather abruptly from layered rocky to going up, up, up? It's almost like I want to put my hand on the contact, the geologic contact. Maybe I can over here. I hope you can see it, but there's a little bit of a ramp for me to come up here. This is about as close. I still can't reach it, but I can get closer. So what you're looking at here is a sharp boundary between layered rocky, and then we suddenly don't have the layers, and we have something called massive. And massive to us in geology means, I'm going to pull back now. Massive to us means, all right, we got traffic here. Hang on. Hang on, Patrick. I'm going to say, yeah, this isn't a bad shot. This also shows, oh, this actually shows better, doesn't it? Look at our layers, rounded rivers, rounded rocks, cascade source, and then up higher we just lose it. And from below, I'm hoping we'll look at a couple chunks of this, but I hope you can see how different it looks from below, this massive stuff. Now, massive to us means no layers. No layers and hardly any rocks, but if you look closely, there are rocks, very white rocks down here at the bottom of this massive unit. But it's a very different look to our truly layered rocky unit down below. Trying not to tell the story yet. I'm trying just to help you make some observations. Each time I want to cross the road, I see there's another car coming. It's late morning on a Thursday. Let's try to swing around one more time. I've got it as wide as I can. Great spot, wouldn't you say? Great spot. Yeah. Layered rocky, and then up above, we lose the layers, we lose the rounded rocks for the most part. Now let's pull back. There's no traffic at the moment. Let's get across. Crocs full of sand. Crocs full of sand. You're looking south right now to Monashtash Ridge. You're looking east, back towards Ellensburg. And now you're coming back around to see our exposure. Okay, now that we're further back, can you see our important boundary that we just saw? Our important boundary is right in here. Everything below my hand, everything below my finger, layered and rocky. Everything above my finger, no layers. Oops, somebody stopped to look at some geology here. No layers and hardly any rocks. But let me throw a couple rocks over there. Again, I'm going to check the road for traffic, but I'm going to go for it right now. Look at this up in the layered unit. Ready? I'm going to throw a rock up there. Right there. Did you see it? That area has a bunch of rocks that are just kind of floating. So this is Jim and Lana. They just happened to be driving by, and they're trying to find the Hicks Butte gneiss that we were looking at a few days ago. So I'll keep 6 feet apart from you here, Jim. To get up to Hicks Butte, right, so South Cle Elum is where we're starting. And I've done 2 episodes recently. So one was going up 3350 to get to Peel Point.
Right.
But that's not what we want for this. So
That's
instead,
this one,
that's this one here.
This one.
It's
okay.
this one here.
All right. And how far up? I mean, you just have to look for outcrops. But how far did you go?
I was filming before you top out. So here's Hicks Butte.
Right.
I didn't really technically get to Hicks Butte.
Okay.
So the place that I was so excited by with the real zebra stripey stuff is right in here.
Okay.
Before you kind of get up. So I kind of between that hairpin and that hairpin.
Okay.
And you'll see a number of outcrops.
Now, this other spectacular place.
Yeah, it's fun to run into you guys.
Yeah, we were.
It's funny, we're driving along. That's Nick.
and it was just
pull over, Henry.
So classic to see you walking down the damn, gutter, filming and talking.
Yeah.
So I'm assuming that, again, there's a couple of choices. I mean, there's this road over here, this 115, but I'm assuming that it's probably 117.
Well, 4308 is the number.
The principal.
And you just keep on 4308 all the way.
Okay.
The blue schist is right up here.
Up here.
Yeah.
Okay.
So there's no turns. You just stay on 4308 the whole way. Cool. Okay. Good luck. All right. Have fun. All right. Let's get back to our discussion. I hope that you can see that there's plenty of big rocks within the massive unit, but they're just floating. They're like plums in pudding, or as my mother used to make, fruit cocktail floating in orange jello or green jello. Can you see some of those stones that are just kind of sitting there in the middle? Now that is unusual. Oh, here's a good one coming up. Don't worry, I'm walking in the road, but I can see and I can hear. There's nobody coming. You see those guys right up there? This is unusual to have so much big rock material floating within a unit that doesn't have any fine layers within it. What is the story? That observation is very important. And you can hopefully kind of just see that there's a strange look to this fat, massive unit. Almost looks like kind of elephant skin. And one more observation then. One more observation. Hopefully you can see layered rocky, fat and massive with big blocks within it. Pink ball. But then as we go higher, can you see that's another massive unit that doesn't have any internal layering. And another one, kind of a ledge former right here. So there's kind of three major ledge formers. Each of the ledge formers, massive units with no fine layering within it. And yet between the massive units, we do have this fine layering and these rounded stones. Okay, those are the observations we need. Now let's break off some of the massive unit, carry it across the road, and we'll look at some very detailed observations within the massive unit to convince ourselves this is not sandstone. We need page 46. We're at the White Rock out by Dudley Cliffs. And in this first section, I simply would like you to sketch, an outcrop sketch, showing the alternating look between the massive and the pebble-rich layers. One gizmo. Question 4 is still talking about data. The massive layer is not a sandstone. What do you observe in hand sample outcrop view or outcrop view to suggest that this is not a sandstone? Well, you already saw that the massive unit has these floating rocks within it. But here's some of the massive unit in a hand sample. Again, this is some of the big fat stuff that doesn't have any layering. Okay, it's really not a sandstone. I mean, it kind of looks like it. Let's get some smaller pieces. Okay, now I hope that you can see why this is not a typical sandstone. What do you observe? I hope that you can see that it's more than sand here. There's bigger pieces, things we call clasts. A big white clast here that's angular. A tan clast here. Tan to almost pink. So as we rotate around, I'm hoping that you can see that in hand sample, and that's what we call just a chunk of bedrock that we break off and hold in our hand. In hand sample, can you see that there's a variety of sizes of clasts? They're not all sand size. Let me get you a couple more. I collected a bunch of this across the road, busted it open with a hammer, and I'm now showing you hand samples. Okay? Now it's powdery. I'm getting stuff in my eyes with the breeze as I'm showing this to you. And much like on Menashtash Ridge, I can break this stuff open with my bare hands. No big deal. But hopefully you can see the difference. There's another key difference, and that is that the white stuff that we're looking at and breaking with our hands, like there, that's pumice. Very fragile pumice. that I can scratch with my fingernail. Can I get close enough where you can see kind of dust flying off of this? It's very soft, fragile pumice. And that's the biggest, most key observation to make here. We have what looks to be a sandstone, and yet there are these fragile pieces of volcanic pumice that would never survive in a sandstone environment. Now, let's try this. Let me sit down. Will he get up if he sits down? That's the question. Does he make the old guy sounds? Yes, he does. All right. Okay. I'm showing you hand samples from this massive unit. This is good. At least I hope it's good. All right. Okay, this is the sandstone, the Arcosic Sandstone from the top of Menashtash. I hope you watched that one first. I was just up there an hour ago filming. I had a red plaid shirt on. It's hotter now, so I took the plaid shirt off, okay? But it's the same morning. And here is what that sandstone, that Arcosic sandstone that was either a stream or a desert. Do you remember now? I don't see white chunks inside of this, white fragile pumice chunks. And this was the stuff also that was roughly all the same size. What I'm breaking off are grains of sand from 15 million years old. This is the thing that was sandwiched between lava flows. Okay, well, here is what's going on at Thorp. Similar, but important differences. This stuff I can also break, but it's not really breaking like this stuff was. And again, we have these fragile pieces of pumice that we don't have here. And we also have big blocks of things that we didn't really have in the Arcosic sandstone, except for that layer of jelly beans. Except for the layer of jelly beans, we mostly had 100% fine to medium grain sand. But this stuff, again, this massive stuff from across the way, this is what it looks like, and it's got these broken pieces of pumice. So, is this sandstone? It is not, for two reasons. You're looking at big rocks that have clasts of pumice within them. Pumice is the white, fragile stuff that's angular. Because we have angular clasts and fragile pumice material, we know this is not a sandstone formed at a beach or formed in a desert or formed in a river system. Instead, these are pieces of, you got the answer? Volcanic mudflow, also known as, aka, Lahar. Okay, well, before we lose that thought, let's go right back to our view. I'm hoping that you can see that from here, the bottom of the volcanic mudflow, let's do it this way. From here, the bottom of the volcanic mudflow, to here, the top of the volcanic mudflow, is one batch of lahar that came to this area in a matter of hours. And the river deposits below and the river deposits above, that's thousands of years worth of time. So I know that in general, when you're in geology, you kind of think about long periods of time and everything is happening very, very slowly. That's true to a point, But here, this volcanic mud flow is a batch of stuff, a lot of material that came in very quickly. And that's a volcanic hazard, of course. So you probably have questions like, what's with the pink ball? Well, many of us interpret the pink ball, let me get a decent shot of it. Actually, first of all, can I zoom in on the pink ball for you? You see that there's big pumice rocks. I mean, that's not my hand now. This is a huge boulder up there that's got these big light gray pumice clasts within it. Many of us interpret that big ball up there as a near source block. In other words, something from very close to the volcano. And then here, this big block is sitting on top of this volcanic mud flow. I don't think that's an accident. This big block just surfed in on top of the mud flow. So this is probably 40 feet of mud flow with a big old block sitting on top. It all came in one Tuesday morning 10 million years ago. So an obvious question is, which volcano erupted to make these volcanic mud flows? Now that we know that they're mud flows, who did it? And the age is 10 million years ago for these volcanic mud flows, so we need to find a volcano that's been standing for 10 million years. And here in the Cascades, that's impossible. We don't have any cones that existed for 10 million years. Most of you familiar with my programs know that my big message is cones stand for 2 million years at a time and then they erode away. So if this is 10 million year old deposits from a 10 million year old stratovolcano eruption, we have to go find a place where a cone used to stand, and Paul Hammond and a few other research geologists and field mappers have found the source. The source is to the south. The source, in other words, where the volcano stood to make these volcanic mud flows, used to stand near Bumping Lake, which is behind me. You're looking in the direction now. Can you see it? No, you can't, because there's 3 big ridges between here and where the volcano used to be. Bumping Lake near White Pass or near Chinook Pass, west of Yakima, is the source for these volcanic mud flows. And you're like, I'm thoroughly confused. Number one, because where's the volcano? It's gone. It's been eroded away. Pear Butte is one of the places that you can find on a map that is a portion of that ghost volcano that made this stuff. But if you know the area, now you're really confused, because you're like, I thought volcanic mud flows follow river valleys, and there is no river that goes from Pear Butte to Thorp. And I agree. Today, there's not a river that goes from Pear Butte near Bumping Lake to Thorp, Washington. But there used to be. Before Menashtash Ridge, Umtanum Ridge, some of the other ridges, before those ridges started to knuckle up and grow, before that, there was a river that flowed from Bumping Lake area to Thorp. And these volcanic mud flows essentially flowed north-ish. But since that time, ridges have grown, have changed the river drainage patterns, and so it's unwise to simply look up this Yakima River and wait for the next volcanic mud flow. Now, speaking of that, we need to cue the traffic. We've had traffic for so much this morning. Now I actually want a car to come down the road. I'll wait. Okay, here's the volcanic hazard we're talking about. It's a hazard. You have just a few seconds to figure out what you're going to do when a volcanic mud flow is coming down your river valley. You see this truck coming? That's about the speed at which we have these volcanic muds from valley wall to valley wall coming down the valley. You're not going to get in a car and outrun this thing. It's not a good situation. Ah! I survived. Not bad. Well, that's probably enough for today. Hope you enjoyed interpreting after observing these volcanic deposits near Thorp, Washington. Pretty cool and pretty convenient to have so close to our campus. Thanks for joining us. I love you. We'll see you next time. Goodbye.